This is the 7.7-8.1 test review. Number 2, non-calculator. This particular problem again is asking us whether the integral converges or diverges. These are a little bit more difficult to tell that they're improper because these are the ones where the limits are at an asymptote. A and B, both the upper limit is at the asymptote, and on C it's in between. So we'll have to split letter C up just in case. Okay. So on this first one, I think we're going to do u sub. So let's have u equal 4 minus x squared, and then du will be negative 2x dx. We solve for dx here. We get du over negative 2x. And let's see what our integral turns out to be. So we're going to have an x here. This is going to be u to the 1/2. I'll probably change that to u to the 1/2 here in a little bit. And then dx is du over negative 2x. Let's go ahead and figure out what the limits are. So when x is 0, 4 minus 0 squared is 4. And then when x is 2, 4 minus 2 squared is 0. It's really okay that those are upside down right now. The math will work out fine. You can switch them if you want, but it's not necessary. Okay, so I'm going to rewrite this integral as negative 1/2 integral from 4 to 0, and I'm going to call this u to the negative 1/2 du. All right, so let's add 1 to the exponent. So u to the 1/2, there's a negative 1/2 already there, and I need to technically divide by my new exponent, which is 1/2. That's the same as multiplying by 2. I'm just going to sneak that in there. 4 to 0. Okay, so this is really, I'm going to write it one more time, negative u to the positive 1/2 from 4 to 0. All right, we're going to plug the 0 in first, so negative 0 minus, and then we're going to have negative 4 to the 1/2, so negative 2. So this is positive 2. So 2a converges. On letter B, I am just going to go ahead and do the antiderivative there. There's no need. It's just an x to the 1, so I know this is a natural log. So natural log of x minus 2 from 1 to 2. And so we're going to end up with natural log of 0 minus natural log of 1. This is where the absolute values also can become important, because I know that could be a negative, but that's sort of why we plug put the absolute values in there. Natural log of 0, however, is negative infinity. So this one diverges. Again, that's thinking about limits. It's not actually infinity, it's what it's heading toward. Okay, technically this next one is one that we need to split. So I'm just going to start with one part of it, because just a reminder, if one part of it ends up being divergent, we just get to stop and say that the whole thing diverges, because we don't really know what infinity plus negative infinity would be for sure. So I also rewrote this so I could do reverse power rule, and again I split this right at the spot where there would be an asymptote. So let's see here. This antiderivative is going to be add 1 to the exponent, divide by my new exponent. Luckily the derivative of the inside is 1, so I don't have to worry too much about that. So I'm going to rewrite this just so it makes sense for my brain of what I'm plugging in and what I'm getting. So when I plug in the negative 3, I'm still going to end up with something on the bottom that's kind of impossible to work with. It's actually infinite if we think about slope in a way. So this is just going to diverge because there's nothing I can do about that.